Okay, this is page 3 in your packet for Unit 7 for algebra. Describe the translation from the parent function using the translation rule. So, all of these, 3, 4, and 5, are written in vertex form. And so one way to look at vertex form is y equals a times x minus h squared plus k for the quadratics, or y equals a x minus h plus k with the absolute value. Okay, and those are considered the vertex form. The h and the k values have to do with translations, and the a value out front has to do with how steep the graph is, either how steep or skinny it is versus how wide or flat or fat the graph is. So the a has to do with how the slope or the rate of change is working. The h and the k just have to do with where the vertex is, and so we're going to relate that geometry to our vector notation. Okay, describe the translation from the parent function using a translation rule. So this +2 on the graph, outside the graph, says that you're going to take that parent function, y equals absolute value of x, and you're going to add 2 to all the y values. So that's going to cause my graph to shift up 2. Okay, I'm going to pull up Desmos and show you what that looks like. So y equals absolute value of x. Okay, that's shown in red. And if I do y equals absolute value of x plus 2, in blue, you can see that the vertex is up 2 points, but all of the points are up 2 points. So the vertex right here at 0, 0 is now at 0, 2. Another point on my graph, this is 2, 2, is now shifted up to 2, 4. Okay, everything went up 2 units. Okay. So on my graph, y equals absolute value of x plus 2, since I'm going up 2 units, for vector notation, my vector notation would say 0, 2, because I'm not going left or right, I'm just going up 2. If I wanted to use coordinate notation, I would say x, y becomes x, y plus 2. All the y values are going up 2. If I look at number 4, in number 4 I have a -1 squared and a -5. So this is going to move my graph to the right by 1 unit, and it's going to move my graph down by 5. And down by 5 probably makes sense because you have a subtract 5. If you're wondering about this right 1 on the inside, well, if you remember from last year or in our algebra program, we talked about how we do the opposite of what's inside the parentheses or inside the absolute value. X minus 1 squared is actually moving the entire graph to the right 1. And so we can look at that on Desmos to show you that that's true. If I have x squared minus 5, so if I go back to my Desmos graph and I get rid of these absolute values and clean this up, we have y equals x squared. Okay, there's my parent function in red. If I want to change that to y equals x squared plus 5, it's going to shift the graph up 5 units. So now my vertex is at 0, 5. And if I put that 1 in there, y equals x minus 1 squared plus 5. Notice how it moved my graph 1 unit to the right. So that -1 on the inside actually moves it to the right 1. So when you're doing an algebra transformation, the inside number does the opposite of what you would expect it to do. So that means that my vector notation is going to be 1 minus 5. Okay, right 1, down 5. And my coordinate notation is going to be xy turns into x plus 1, y minus 5. Number 5, we have this absolute value, y equals x plus 6 minus 3. So again, the number inside, this means I'm going to go 6 to the left. It's the opposite. Now you can think about it as if I have this plus 6 and I subtract 6 from it, it gets me back to the x. So 6 to the left, and then I also have this down 3. So as a vector, it's -6, -3. Whoops, need to use a vector, not a parenthesis. And then for coordinate notation, my xy becomes x minus 6, comma y minus 3.